Hello, guys. Welcome to the new series of HashiCorp workshops. So, in this specific series, what we are going to concentrate on is we are going to learn implementation by doing it. So, as you all know very well, that practical implementation and practical learning is a key towards getting hands-on knowledge, and it helps you to gain more confidence in terms of what you're delivering and what you're working upon. So that is the reason, keeping that in mind, this is the new series idea that I have came forward with. And as part of this series, I'm opening with this our special guest, that is Sandeep Das. So Sandeep Das would be, I would say, inaugurating this specific workshop series of YouTube that I have started. So very I'm very actually excited. I hope you all are also excited. And let me go ahead and call our special guest and the speaker for today, who is going to provide the workshop on Terraform. And the topic is multi-cloud deployment using Terraform. As you all know, that Terraform is a cloud agnostic tool. We have been hearing it, but let's see today how it does a multi-cloud cloud deployment on AWS, Azure, and Google Cloud. So let me go ahead and introduce our special guest, that is Sandeep Das. Hi,
Hey
Sandeep.
everyone, hi, and welcome everyone. So let's have a nice session, and it's great to be here and talking with Dheeraj. Always exciting, and let's see what we'll be going for today. So Dheeraj, yeah, okay. So now we'll get started without wasting any time. Of course, we'll just go right to the point. We know it's Saturday evening. You'll be excited to learn. Also, we have family and other things, so we'll be not waiting. Or we'll not let you wait for any longer. So let's get started. We'll first learn a bit theory because that is also important, and then we'll jump to the practical part of it. Okay. So very first, like if you are very new to this, what exactly is infrastructure as a code? Now, infrastructure as a code is an approach for managing and provisioning IT infrastructure through code and automation, and rather than using manual process. So normally when you learn, what do, we manually create the VPC, we manually create the IAM authentication, we manually create the instances, right? It's good for learning. But if you think about the production use cases, you might be sleeping at night, maybe 2 a.m., 3 a.m., and something bad happened, or maybe some very huge workload coming, or maybe somehow any reason your infrastructure got faulty. Now, if anything can happen, or any region could be down, for example, could be n number of reason, and you want immediate deployment, manually think about that. How much hell would be to manually get all the resources? Now you have the rescue. You can use infrastructure code services to instantly, or maybe within few minutes, create your entire infrastructure. We can have that now. So main point is, instead of using manual processes, we can use configuration tools. And in this approach, infrastructure is defined and described in the code file. So just like, and it can be any coding file. It can be your normal programming language. You can use your own programming language to create cloud infrastructure, or you can use specific language that is described, or that is defined by the service provider. Okay, we can use their language as well. For example, Terraform, we have HashiCorp language. Okay, and we will be coming to that as well in short. So, and which is to, and another aspect of this. So like how you store your application code in the your GitHub repo, we can store our all these, because ultimately you are writing infrastructure as a code, right? And here also we can store all our logic, all our mapping and everything as a code, and we can version manage it using any Git platform. Okay, and which allow us for easy tracking, tracking of the changes, versioning, collaborating, blaming. Suppose someone doing wrong, we can just blame it. PR request to only allow the request that is reviewed by the users, and we can have all this thing. Right now, IAC enables developers and operation teams to automate the process of creating, deploying, and managing infrastructure. Uh, and we can do all the stuff that you can do manually. We can do exact thing, even more than that, via automation. Now, such as servers, we can create server resources, network resources, storage resources, security resources. We can create all, and there are a lot of frameworks, a lot of tools available for that. We'll be coming to that shortly. Also, what are the tools we have? What are the most popular tools we have? Okay, we'll come to that. Now, this creating using automation to create the resources, not just create things faster, more reliable way. It also give you an opportunity to create it repeatable, to maintain the consistency of creating the resource. Every time it will be creating exact same way. That is also you can have via infrastructure as a code. Okay, so main key point or key takeaways I will say. First, you can write your infrastructure, say server resources, your storage resources, it could be any cloud resources as a code. You can version manage it in any Git, maybe GitHub, Bitbucket, or maybe GitLab. And you can even do GitOps, which is like from the directly from the source, you can run CI/CD pipeline and you can deploy directly. You can have all the features. Now, let me come to the what are the say popular IC tools you have, and you'll be amazed to know there are many, not just one or two, many. First and foremost, of course, our Terraform. It's an open source IC tool created by HashiCorp that support multiple cloud provider, and that is the topic of today, isn't it? Which allow us to create, manage, and modify infrastructure using a declarative language called HCL or HashiCorp configuration language. Now, what is the second one? That is AWS proprietary resource, AWS Cloud Formation. It's a service provided by AWS Web Services or AWS, popularly, guys all know that allow users to define and manage AWS resources using JSON or YAML language or templates, you can say. Then we have Azure Resource Manager or ARM templates. Now, it's a language used to define and deploying resources in Microsoft Azure cloud infrastructure. Similarly, in GCP, we have Google Cloud Deployment Manager, a service that is provided by Google Cloud Platform or GCP that enables users to define, deploy, and manage Google Cloud resources using YAML or JSON templates. Then we have configuration management. So if you want to install software in different cloud services and all that, for that you have Ansible. Now, Ansible, what is Ansible? Ansible is an open source ISE infrastructure code or say configuration management automation tool that can help users human like which can use human readable language such as YML to define infrastructure, say, or software resources or configurations. Okay, mainly software installation you can do easily via Ansible. Okay, and you can do that as very scale. So you can have 100 server, 1000 server, 2000 server, doesn't matter. You just need the host addresses, maybe private IPs or public IPs or their host names, and you can connect to the instance directly via SSH with certification. And then you install softwares, remove software, you can do all that other cool stuff. Okay, and just like Ansible, we have Puppet and Chef. Now both are very popular, like Ansible and Puppet and Chef are both are very popular configuration management tool that uses domain-specific language, is DSL, to describe and manage infrastructure component. Now, Ansible and Puppet Chef all kind of do similar kind of stuff. All have the capability to do configuration management and create infrastructure resources as well using different SDKs that is provided by the cloud service provider. We can have all that. Okay. Now, by adopting IOC or infrastructure as a code, organizations can benefit from improved collaboration, reduce human error, because the moment you create manually, there is always chance of error, which is not the case all the time. I will say all the time because everything can happen. I mean, error can happen anywhere, anyway. But using ISE, it can reduce a lot of the chances of error. It will be a lot reduced. Okay, and it's more predictable deployment, easier management of infrastructure resources. We can have all this benefit just by consuming ISE tools. Okay, now let me come to the now one of the very most important tool, which is the topic of today, that is Terraform. Now, what exactly is Terraform? Okay, now Terraform is an open source infrastructure as a code tool created by HashiCorp that you already know that allow us to provision, manage, modify infrastructure resources across various cloud service provider, and that is the topic of today actually. We'll just not learn one cloud, second cloud, or just two cloud. We'll see how using Terraform we can deploy resources in all major three clouds, and we can have all that from just one single tool, that is Terraform. And it not just limited to cloud service provider, by the way. You can have many other tools such as Kubernetes services you can deploy, you can manage via Terraform. You can have other many such tools. Okay, it have a separate dedicated section for providers, and you'll be amazed to see how many providers it can support. So you can go and check out there after the session, by the way. Now, it uses a declarative language called HashiCorp configuration language or HCL, and HCL language is not actually just limited to this Terraform. In future, when you work with Packer and all other such tools, you might see its usage. Okay, and we of course Terraform uses this HCL to define infrastructure component in human readable formats. Okay, so you don't have to be a programmer or very knowledgeable in coding. You can, if you don't even have such knowledge in programming, you can still get started with HashiCorp, this configuration language very easily because it's more human readable. That's the reason. Okay. Now, Terraform enables user to create and manage infrastructure resources by writing configuration files that describe the desired state of the infrastructure. So, what ultimately you're writing that what you want, what you expect, or what are the resources that you expect to be created, or maybe modification that you define, and Terraform help you achieve that. Okay, and this configuration file are executed by Terraform CLI. We'll see anyway in while showing the demo, which interact with the respective service provider APIs, because every service provider which have the provider will be added as a provider for Terraform, and Terraform will act via these kind of API libraries or providers to access the resources. Okay, and via that API, of course, Terraform will create resources, delete resources, modify resources, will do all the cool stuff. Okay, now we learn about like what is ISE2. I mean, what are the ISE tools? I mean, what is ISE first at the beginning? Then what are the ISE tools? We learn about Terraform. Now, why people love Terraform? By now, you should already know why people love Terraform. But just as a kind of a reminder, I would say that Terraform gives a lot of feature. I will just point out the most important points. This is provide support, provider support. It has a large number of provider, could be AWS, Azure, GCP, Alibaba, lot of services. Okay, it uses a declarative language, that is HashiCorp configuration language, which is actually very easy to understand and easy to learn also. Then you have modularity. Terraform have kind of native support for modules, so you can create modules for whatever feature you want or any requirement you have, and you can create the modules, and you can reuse the modules also multiple ways. Then you have version control. So since it's a ISE, infrastructure as a code, we'll treat the infrastructure just like how we treat our application codes. So it will also have, say, very interestingly, we can have version management. We know who is the author, we know who is making what kind of change. We can have single source of truth, what change happening, what is the actual state of the servers via from the Terraform codes itself. And this is very cool, isn't it? Now we'll have Terraform state management. So what is the current state? You can just read the Terraform state file and you can have all the data. Okay, then you have plan and apply. Even before creating your resources, you can actually see what are the resources going to get added. That way you will see, okay, is it, this is not getting properly added, or this might remove. All this information actually they display before creating it, which will help you to kind of make a decision. You should be able to apply it, or you should first make modification and then apply it. So you'll have all these choices, which make kind of your this like this all this cloud management a lot simpler. Okay, so now we know like what is Terraform and what Terraform does, or why people love Terraform. Now let's jump to the main part. Okay, that is how you can simply create the different for resources for different cloud service provider. And before that, I will show you actually how to add the configuration, and that is actually configuration adding part is most important while you are working with multi-cloud. Now the part we are talking about multi-cloud with Terraform. So what exactly I'm meaning by multi-cloud deployment Terraform? So multi-cloud with Terraform refers to the practice of using Terraform to manage infrastructure resources across multiple cloud service providers such as AWS, Azure, GCP, which is our today's topic, by the way, simultaneously within a single project. So when we have a separate projects, in a single project or single code base, we will have resources for Azure, as AWS, Azure, and GCP, which is we are calling a multi-cloud deployment or multi-cloud management with Terraform. Now, this approach offers organization the flexibility to leverage the best services and features from different cloud service provider, because not all cloud services are perfect, but all might have some interesting features which you want to cherry pick. So you want some features of AWS, and you want some feature of Azure, you want some feature of GCP. You can have kind of, and all that connected somehow. You can achieve that with this multi-cloud deployment itself. Now, Terraform provider-based authentication architecture. So Terraform have this provider architecture. Like we have GCP as a provider, we'll have AWS as a provider, we'll have Azure and AWS. So all these main major cloud service provider will add as our provider. This is how this is the architecture how we access multi-cloud, or we can achieve multi-cloud management. Now each provider in Terraform is responsible for managing resources within a specific cloud service platform or service. Of course, you cannot use AWS provider to manage Azure resources, or you cannot use Azure provider to use GCP resources. So AWS provider will manage only AWS services or resources, and we'll be seeing that, we'll be understanding that in shortly. Okay. Now, you can create and manage resources across various cloud platforms with this multi-cloud approach, unified way. So, in a single place, in a single code base, you will see, okay, GCP have this many resources, Azure have this many resources, and AWS have this many resources. So, you will have that overall view from single project. That is why it's also getting very traction these days. Okay. Now, benefits, of course, consistency. You can see the unified infrastructure language across all cloud service platform. So just using one single tool, that is Terraform, you can manage all the major cloud service providers. Right. Now, simplified management using single IC tool for multiple platforms, which is helping you to have simple management. Flexibility. Now, desktop read approach for cloud service selection, because just if you want to say you are developing some resources in GCP, but for some reason you want to migrate that quickly to Azure. And since it's single, only Terraform only, you can just have the resources equivalent for other cloud service provider. You can quickly migrate. So you have all this kind of flexibility. Now, reduce vendor logging. If you go for multi-cloud approach, of course, it reduces your vendor lock-in state. Okay, and cost optimization. Of course, you use select simply where do you find resources most cheapest. Use that one, and you can have everything connected later on. So you'll have this kind of exciting features and benefits with this multi-cloud architecture by Terraform. Now, very first thing we'll actually go through, that is how you configure authentication, because the moment you are going to work with AWS or Azure or GCP, you have to make sure that you are configuring your project right. Okay, so that you can access the resources. If you don't configure the access properly for your Terraform, then Terraform will be not able to access all the resources, which is I'm coming right now. So if you see here, for AWS, this is how we can manage the say authentication, and there is not one, two, or like limited way. There are multiple ways you can configure your AWS access for Terraform. Okay, first one is that environment variables. You can see as three environment variable: AWS access key, like you have to supply AWS access key, AWS secret access key, and this AWS session token is for optional. If you use any temporary token, then only you need to use it. You can ignore that one, but mainly AWS access key and AWS secret access key you can pass as environment variable, not as a part of your code. Environment variable, that means you're injecting while maybe creating the instance, or maybe before running your Terraform code, you're just injecting in the environment. Okay, this is the code. Export in shell script, you have to run export, then the key is AWS access key ID equals then your actual value. Okay, and again, remember, I'm repeating every time because you should not or never store your actual access keys or actual credentials in your code base. That's anti-pattern. That should not happen. Okay, now that's one way to using environment variable. Second way is actually using shared credential file. So there is AWS CLI, which you can just install AWS CLI from AWS official website. Just Google about it. It's very easy to install. Many resources already available how to do it. I'll just not repeat myself. But after you install your AWS CLI, simply run AWS configure command, and it will ask you to enter your key and profile. You can even create profile also. Go to your AWS file. There you can just go to this file, like dot aws then slash credential, and you can add a profile like this. So I'm creating default profile, so just third brackets then default. If you want something else, maybe personal, instead of default just mention personal, and you just mention this AWS access key and AWS secret access key, and you actually mention that one. Okay, now you can like, this is how you first add your profiles, and in the actual AWS actual provider where you're configuring provider for AWS, they mention what is the profile that you're going to use, and actually I'm using this method. Okay, now there is a third way using credential in the Terraform configuration, which is to be honest, I will not personally recommend, because this is how you are going to expose your keys to your Git environment, which is not recommended. Okay, this is when you are testing is fine, when learning is fine, but you should not store this particular way, which is ultimately you're mentioning provider AWS, you're mentioning AWS provider and configuring region, and you're passing the access key and secret access secret here. But this is not the right way. Okay, you can learn for development, but I will say first one and second one is the right way for AWS to configure your credential for Terraform to create resources in AWS. Okay, now that is for the AWS. Now next one is actually the GCP. Now GCP also, just like AWS, GCP also support in multiple ways. Like you can see here, environment variable. You have to just set this command. You have to run set the Google application credential environment variable to the path. So export Google application credential, and then you have to specify the path to the key file. Now, how to generate the key file? You have to go to your GCP console, then you have to go to IAM admin section, then go to service account. There you create service account, then provide name, description, and click on create. Grant the necessary IAM roles and service for that account, and simply continue. You will get an option to download the JSON file. Okay, and then you can just store in some place, and you can give path to that. Okay, that's one way. Uh, Now this is where you don't have to actually mention, like you have to define the provider anyway. Provider Google, project ID you have to provide, and region you have to provide. But if you give, I mean, supplies export the particular key file, then you don't need to mention that particular path in the provider. But if you don't use this environment variable, then you have to specify credential path to the particular provider section. Now, what I will recommend, even if you mention, like if you don't can't use, the best way is to use this environment variable Google application credential. But if you can't use any environment variable, then this credential file that you're mentioning should be outside of your uh, git repo. Okay, you should not store that credential as a part of your git repo. That's not good thing. Okay, the third way, if you're using application default credential ADC, so if you don't explicitly set credential in a Terraform configuration or via Terraform via environment variable, Terraform will use ADC or application default credentials, which are automatically provided when you're running the Google Cloud resources such as Compute Engine, Cloud Run, or Cloud Function, and ADC can be deployed obtained from the gcloud CI. Now, I personally prefer the gcloud CI because I'm doing a lot of cool stuff with the gcloud CI. Again, how to install? Simply go to Google and like install. They have a package for Linux, Ubuntu, and Windows also. Okay, so you can just install from there. And after you install the gcloud CLI, simply run gcloud auth, then application default, and login. If you run this particular command, it will open a new browser tab, and you can configure there. Okay, so this is how you can configure GCP credentials. Okay, now uh, okay, now the third one, and the main, I mean, not main one, this third main, another like third main cloud service provider is Azure. And Azure is quite famous, by the way, these days, like giving rivalry to AWS. Now, if you like, what are the main, or what are the multiple ways you can configure Azure access the credential or authentication for Terraform? Okay, first option is Azure CLI, which again I prefer the CLI option. Maybe as a DevOps engineer, I do prefer CLI. Now, if you have the Azure CLI installed and signed in, so you just have to run a command called AZ login in your command CLI, and which is like Terraform can automatically, like if you after you do the authentication, Terraform will automatically fetch the credential from the cloud. The second way is actually via the environment variables. So where we have to supply export ARM client ID, export ARM client secret, export ARM subscription ID, export ARM transaction ID. Anyway, if you have the CLI, if you run the AWS CLI login, sorry, not CLI login, it's AZ login, it will export these values, okay, in your screen. So you can use that as a environment variable as well wherever you need it. Okay, I prefer two way, either using AWS CLI or using environment variable. That's most secure way. Now the third one, which is not so secure, but while you're doing local development, I would say that's fine. So it's using Terraform configuration. In the Terraform file itself, you mention or supply the SIG client ID, SIG and tenant ID, which is, again, I'm repeating, this is not recommended. For learning development, fine, but for production use case, this is not recommended. First two are the most recommended one. Now, although not recommended for security reason, you can provide the credential directly in your Terraform configuration using client ID, client secret, and configuration ID, and tenant ID attributes, just like passing here. You can do for development, again for the development you do, but above to AWS CLI and environment variable are the most preferred way. Then the fourth way is manage service security identity. So manage service identity, or MSI. Okay, when running Terraform on Azure like a virtual machine, or Azure services such as AKS, like Azure Kubernetes services, AKS cluster with MSI enabled, Terraform can automatically use the managed identity for the authentication in the Azure AM provider block. Set the for that, actually you have to, in the Azure RM provider block, you have to mark as a true. That is one way. And then you just have to, in provider itself also, you have to specify like use MSI is equal to true. Then only it will work. So if you're running from the VMs, what you are giving the authorization and all, there you can use this kind of. So either AWS Azure CLI, either environment variable or the last one, that is via the managed service identity or MSI. These three are the recommended way. Most recommended, I will say, easy using environment variables. Another way I will say easy is CLI and managed service also. If you are running your workload via the virtual instances directly in the cloud, then you can go for this MSI. Okay, so these are the ways you can configure AWS credential, your GCP credential, and your Azure credential. Now is the demo time. This is the moment where I will show you the code, and we'll go through it. But how I did? Yes, here you have it. So very easy. I created a application which I think Dheeraj will share the code with you guys later on. Um, Very simple application. If you see here, I use the profile. So if you see my presentation there, I was mentioning using the you can just mention the profile multiple ways, but this is another very easy way using profile. I can just specify the region and supply the profile. For that is for AWS. For Google or GCP, I'm just saying provider Google, then I'm giving the project ID, then I'm supply the region, I'm supplying the zone. That's it. For Azure resource management, I'm just giving nothing. It's simply features, then to third, second bracket. That's it. This is how easily, and see the code. I'm not supplying a single credential in this places. That how it should be for you also. You don't want to share the credential directly. There are many ways I've shown you. Choose any way as you like. Environment variable is, I will say, pretty easy way you can achieve this. So just don't mention your credential direct in the code. That's bad, very bad. Okay. Now this is how I'm configuring in the main. You can have another file called providers, and you can mention there in the main also you can supply. So ideally, actually, how it should be, you mention provider in provider tf or in the main file. Then you'll have modules for each and every cloud resources. Then you do it. Now, if I cover the module, it will be another big session, which I don't want. Let's keep it to our purpose, which is multi-cloud, right? So we have configured a multiple clouds: AWS, Google, and Azure. Now let's create the AWS resources. So there I just created AWS VPC first, then internet gateway using this AWS internet gateway, then AWS subnet, then AWS security group, and then AWS keep pair. Now keep pair, actually I'm supplying my local ID. I could have used existing one. I can usually do that, or I can just create like this. Okay. Then AWS instance, I'm just creating an instance. This ID, actually you can go to AWS and in the launch AMI section or AMI section, you can just fetch whatever required image you need. You can just add it there. Instance type for demo, I'll just starting with a very simple T2 micro instance. Then I have mentioning subnet ID. Subnet IP is actually the subnet I'm creating here that I'm mentioning. So AWS subnet.example.id, which is given a name that way. Whatever name you mention actually or create, you should be using that one. And you can see here VPC. I'm supplying VPC security group ID, the security group that I've created here. I'm supplying there. I'm allowing only port 22, just connecting with the instance if I want to, supplying there TCP and allowing for all the IPs. Now again, for production it will be different. I'm not talking about the production use case here. I'm talking about how you can configure multi-cloud. That's the total agenda, right? So this is how I'm just simply specifying AWS, like creating AWS instance, simple resource you can say. I'm creating with AWS. Similar way for Azure, I'm creating Azure resource group first, then Azure virtual network, then creating Azure subnet, then Azure resource management network interface. Now all these things, okay, Azure resource group, Azure virtual network, Azure subnet, all these names, okay, actually coming from the this provider, okay, this Azure AM. The moment you specify the provider, Terraform will like init. When you do init, Terraform will install all the APIs, and not only you will have everything available, okay, just like Azure, this all these things. Then Azure public IP, because I'm creating a public IP, so it's publicly accessible. Then I'm creating a virtual instance. So Azure RM underscore Linux underscore virtual machine. Then the name of the machine that you're creating. You're supplying name, location, resource group name, network interface IDs. Now network interface ID actually I've created here. So Azure network interface, then the name, then dot location. Sorry, the the ID. Then we have size standard v1. Again, every cloud have its own way of naming things. So whatever cloud service you use, just go to that cloud service by documentation and find out, okay, what is the size that is you need. Okay, that's how you should do it. Then in OS disk caching, read write, you can enable storage account type standard LRS. Again, it's all depends on your requirement. Based on your requirement, you should have it. Now, one point I will say very important while you're working with multi-cloud, of course, you need multi-cloud knowledge. So basically, how you manually create it, how you manually configure it, all the knowledge you need before actually starting everything automation. Okay, so you need basic knowledge in the cloud service first, then then only you can create this dynamic view after the reading the documentation, by the way. But yeah, this is one very cool way of creating resources. Instead of manually creating it, I'm using Terraform templates to create this. Okay, and then I'm giving source image reference, which is publisher canonical Ubuntu server. SKU is 18. Whatever version you need, you can just specify here, version latest. Then the name, I'm specifying the name here, specifying username here. And instead of defining password, I think is very good way to use the keys. So I'm just supplying the keys for the username, supplying my personal SSH keys. Okay, then I'm making sure that no password authentication enabled. So disable password authentication true. This is how I'm creating resource for the Azure. Exact same way, you can say more simpler way. I'm creating first Google compute network here. You can see auto, like if you want the subnet to be created automatically, make it true. I'm creating the subnet via the code. So Google compute subnetwork example. What is the name? Again, all these example means the names. Okay, I'm giving name as example. Okay, just to be easily understood. Name is example subnetwork. I'm giving the CID range. Then I'm specifying the region. But this region and everything, these names should be ideally variable. But this is the demo, which is very small demo, right? So I'm just not using that much variable, but you should be using variable, by the way. Then network, I've already created a network resource here, right? Google Cloud Network example dot self link. There is a network I'm supplying here. Similarly, I'm giving the firewall. I'm just giving the network, which is the main network. This one, Google Compute, yeah, network. This one. Then I'm allowing port 22, and the source ranges is actually from everywhere. Ideally, this source range should be your personal IP or maybe your office or company IP. Okay. Then you have this Google compute instance, just like we create instance for Azure. This one, Azure VM Linux virtual machine, and AWS this instance. Similar meaning is actually the GCP. We call it Google Compute Instance. Okay, and there you are giving name. You are giving, again, just as I mentioned, every cloud have its own way of specifying the instance type, which is how much RAM, CPU, or maybe network capability or inbuilt storage you will have. Those you those you have based on the machine type, and you can go to respective clouds maybe pricing page, maybe their documentation page, to find out what should be your ideal machine type. Okay, this depends on you. There I'm giving the boot disk, I'm specifying the image, what should be the image to get the instance, the network interface, which I've created subnet here. This one I'm mentioning here, and then access config external IP. Now here also SSH keys, I'm giving the SSH key name, and SSH key from my personal SSH keys I'm supplying. So these are the way I'm just creating the resources as AWS, Azure, and GCP. In the main, we just have the reference of the providers. Okay, there you can even give the versioning and all that if you want. You can give. I didn't overcomplicate the stuff. It's very simple. Providing AWS, Google, GCP, all in a single project. Mentioning AWS resources in AWS TF, Azure resources in Azure TF, and GCP resources in GCP TF. Okay, we have that. Now very first step, like suppose you're done with your initial coding, or maybe just you have added this, then you should run terraform init. Okay, and what will do, it will just download all the API related thing in your machine. Okay, in this folder. Okay, dot terraform, you see Azure, all the Azure provider, sorry, AWS provider, Azure provider, and Google provider is actually getting installed. All the API is getting installed. Okay, so this is done. Then second step you should do, actually, let's clear the screen and say done terraform. So like you're done. You're the basic things are done. Okay, sorry, terraform plan. If you run this command, terraform, run this command, It will not create any resources, by the way. It will just tell you what are the resources that going to get created. Okay, so it will just give you an overview. If you want to create it, then you have to run terraform plan. So let's just wait for this instance to it's already done. So you see, it's asking, it's saying that it's going to create 16 resources. It is going to add that one, zero change, zero restore. So it will simply add all these 16 resources, which is it will create AWS resources, Azure resources, and GCP resources. It will create all these resources. Okay, now if you just review it, you find, okay, all good, it will create the multi-cloud of that thing. Simply run Terraform apply. Okay, if you do that, sorry, Terra means that if, so yeah, Terraform apply. If you run that command again, if I can make it non-interactive, but in that case, the possibility of mistakes are high. You should not do when you run GitOps, all this kind of thing. You ideally don't have the interaction available there. So there you run /OI or say auto run, yes, those kind of stuff. But here is, it will ask you like enter the value. If you run yes, then only, I mean, you can review here also. Then after your review are done, you're okay with it, you can run yes, and that will create all the resources across the Azure, GCP, and AWS. This is how easily you can create the resources. You can see the progress here. This is how is creating the resources. And after all this done, I have an output folder where it will simply output the instance public IP, private IP for AWS, for Azure, and for GCP. It will show the outputs. Okay, this is how easily we can have multi-cloud configured app and running. Wow, we did it so fast. So yeah, let it run. And let's see if any guys have any questions related to multi-cloud deployment and all. Feel free to ask. Okay, this is very interesting topic. I mean, many companies actually going for the multi-cloud services. Maybe you might face your next challenge could be that one only. So yeah, any question? Feel free to let us know. I see already Guru is there, Ganesh is there. Say hi guys. Vishal is there. Great. And maybe just your guys are digesting right now. Later on, if you ask any question, you can reach out to Dheeraj later on, or come to me. I'll be happy to answer all the queries you have. Okay, it will take some time, of course, because it's multi-cloud, by the way. Hey Ajay, good evening. Okay, but it's a very actually very small cool project I have created one day back, just for the purpose of demo, by the way. So where you're defining all the provider details. So I'm giving provider details actually in the main. But see, I'm using profile here. For Google, I use the Google CLI. For Azure RM, I mean for Azure, I use the Azure CLI. Now let me show in the browser where you can just install that all this thing. Let me share it. Just a moment. One issue, okay, one issue is happening here. Let's see what is that. It's saying that T2, your request is in time not supported in your request ability zone. Please retry the request not specifying not by not specifying. Okay, some ability zone may not have that one, and I don't have any requirement to create in a particular ability zone. So I can go to AWS and remove that requirement. So it's saying that don't ability zone. So let's check. Actually should work. I can run say T3. I can look at the T3 micro, for example, or T3 small. Any resources. See if that have resources. And this kind of error is expected to come. So don't worry. Any error come, don't worry. You just have to start debugging and fix it. Okay, anything can happen. Just take what you're working for. Okay. And see, next time it will not ask you to create all the 16 resources. It will just ask you to create only the resources that is that is you want to add. See, here is asking to add only or one service, and that is only the resource that is not created. Okay, that is the AWS instance. Okay, see here, it's just AWS instance will get created, so you just have to say yes, and yeah, it will create. If this instance time not supported, we can just add any other instance time, so don't worry, it will get created definitely. Yeah, question is that sir, where you're defining the provider details. This is, I mean, where we are defining the provider from the main, here in main section. Okay, see Azure, sorry, AWS, I'm giving my yeah, this time is created, right? And see, it's now showing all the IPs which are defined in the outputs. Now in the main, I'm providing provider AWS. Okay, profile giving personal, and go for Google, I'm just giving project ID. You can get project ID from the Google cloud service provider, region and zone. Okay, as well, I'm just not mentioning anything, it's kind of more dynamic. uh, One question is that is defining how the application deployed in multi-cloud, like few application will go to AWS, few will go to Azure, we will go yeah, and see, uh, this is okay. Yeah, so this is your requirement. Where do you want to run what? First you create, like first you create the platforms, first you create the servers, then which server you want to run, whatever it is, you will the CI/CD tool do that. In CI/CD tool, maybe Jenkins, maybe other tools, there you mention which server to go for, I mean which server what should run. That is the next thing. Okay, now can you show me where you define the VPC CID in GCP? Definitely. So in GCP, okay, this is the VPC CID. VPC CID, this one, I mean, I'm not giving the VPC part, just the main the subnet level I'm giving it. But you can configure the main compute network. There you can supply all this. Okay, by default, it's getting that one. Even if you're using profiles and environment to store credential, it will not show credential in state. No, it will not. It will not. Ajay's question was there. So even if you're using profile, no, it will not show the credential there. Okay. Mm. Any other questions? Keep it coming. Very interesting question, by the way. Dheeraj, do you have any questions, by the way? You're also a guy with, I mean, a lot of knowledge and experience in Terraform. Okay,
No questions,
go on.
Sandeep. You are teaching. There is no questions.
No, no, I mean, the thing is that you are also working in Terraform for your company, then maybe
I am
past also
actually.
you were.
I am while being on the call. I am also trying to test this out on my second screen.
Great, great. And this is interesting, and see, I remember I got a challenge from a company. They wanted to create an MVP, and they're asking Sandeep, create an MVP, just create a few instances, few networking resources in multi-cloud, and let's see how did that work out. And Sandeep, one more request: can you make us a module? I didn't make a module here just for the sake of simplicity, but if it would have been complicated use case, I could have made a module separate for AWS, separate for Azure, and separate for GCP. That's much more refined requirement. But yeah, I had that kind of challenge, and they pay me good amount, so it's all good. Yeah, seems that I think we covered everything is created and all working fine. This particular project, I think Dheeraj will share later on. No questions so far.
I will create a GitHub repo. In that, I will push all the codes, so people can go
Yes,
over there, and if they have any questions, or if they want to
yes.
make any changes into that, if they see anything needs to be
Let
fixed, they
me
can create a
let
issue.
me add the
Yeah,
my yeah. What happening is that my charge getting it. It's okay. I can have this one. I don't know where I put my charger.
Sandeep,
Give me 1 minute. Huh?
towards wrong screen. This is the right screen.
Huh? Which one?
I
Oh.
said.
No, man. What I'm saying is I have around in my room right now. I have around 8 laptops. Okay, in my room. Okay, if you see here, is one, two, three, four, and here 5, 6, and I have in my pocket another one. So there are 8 laptops I'm working on right now. I mean, not working on. Like I use just on different use cases. By the way, I have to. I have to add my charger. Give me 1 minute. By the way, just I forget to add the charger. you should do it. Otherwise, I'll get disconnected. By the way, I mean, if you go to any company, or if you look at any requirement these days, Terraform, I think one of the most short for the, I mean, or the most demanded skill. So I think everyone should learn it if they want to become a DevOps engineer. Okay. Okay. I've connected my charger. I'm all set. Anyone have any question, feel free to ask. And one more thing is that, uh, if you support, for example, this is my local machine, right? If it is supposed to be running in, say, cloud service pro, and say maybe you're running in Jenkins, if you want to achieve the gitops, okay, those kind of thing, then in the gitops, I mean, so in Jenkins you have the option to inject global variables. That is one way. Or even better, you can just have, specific project specific variables. There you should actually pass on all the variables that is required. There you can, I mean, exact same configuration. Maybe for AWS, this profile part you have to remove. Just remove this profile part entirely, the main. um, Everything else you can keep. Again, this one actually you should make variable. This region you should make variable. That you should do as a part of your deployment. Could be a challenge to other people if they want to, run on different CI/CD tools. Okay. Okay. Oh, there is one question, by the way, from Lakshmikant. That is, when we are running Terraform apply, if it get hang in between, how do we troubleshoot? Okay, so suppose there is two thing can happen. Okay, one thing that, okay, it created resources. Next time you run Terraform apply, just like last time I show you, right? Resource didn't create it, stopped, right? That case, it will just refresh the state, and it will show you what are the resources good added or modified. Okay, suppose the resource that you're going to create, that has no option, that cannot be created, or that can be modified, already created, but you cannot modify where it's all stuck, then that resource will get first removed, and then a new resource on that place will get created. That's how Terraform handles things. Okay, you try to modify. If there is no option to modify, it will delete the resource and recreate. If there is any hanging or such kind of in between, it will just mark that particular resource as a stale or something. I forgot the exact term. Or tainted. Yeah, it will mark as tainted, and it will remove the resource. Yeah. That is from Lakshmikant. Very interesting question. See, people who are joining, so also people asking very good question. It get high in the first apply in that case. It gets, oh, if it's in the first apply, it can hang. And see, it all comes to any resource getting created, and that if not getting, okay, hang in the case, okay, if it gets hang in the first apply, in that case, that means that the is getting timed out. So Terraform is not able to make request to the respective cloud service provider. That is, it's waiting and waiting and it's getting hang. Okay, that's the reason. So you should first configure the resources. In this, maybe you should test out the CLI that you can. Different. There are many ways, right? I will say the easiest way is actually use CLI to see the access is working or not. If all access is working, then Terraform still having some hanging issue. Could be machine specific issue. Just restart, and see that might be fixed. With the IT people, right? Every time any problem happen, first thing you do is restart. But yeah, could be the credential issue, or could be the temporary hang issue. Just restart the machine or service, it will get fixed. Like, there are many ways to troubleshoot, by the way. And you know what? As a DevOps engineer, like, the instead of creating more, we troubleshoot more. So it's a problem, and then we're fixing the problem. People are hiding us. We are paying huge amount just to fix their issues. Okay, that's, we are so valuable. And see, if you become a person who can solve complicated stuff, people will come to you, because if it's very easy, everyone can solve it, right? If very complicated to solve, then only we get the value. Is RKB saying VPC or some other configuration shared between multiple clouds? See, you cannot share resource of one cloud service to another service. Okay, right. There are specific service designed for that. That is different. But in general, one like VPC you cannot share. Like if okay, one VPC in one cloud, you can say AWS. In AWS only, you just connecting with another VPC. That is VPC pairing. That is okay. But the question is that from GCP VPC to, or say Azure VPC to kind of AWS VPC, that's not possible. Okay, yeah, you cannot do. Yeah. But good question. I mean, that can happen. What are the thing or services can be shared? It's a very valid interview kind of question. Also, you just have to say that okay, no, we cannot. I mean, we can define variables. We can create virtual network from single source or a single configuration file. That's different. But we cannot share one cloud resource to another cloud. That how you should be able to answer that. Yeah. Feel free to. Okay. It's a big question now. Show it in the screen, Dheeraj. So I have it's a Rahul question. Then I have created a CI/CD pipeline for the resource deployment. Now, what I want to do is add parameter to Jenkins, wherein X, for example, when I enter variable value, then it should get change in my repo and change repo and get deployed. Okay, let's process it on my brain. I have created a CI/CD pipeline for resource deployment. Okay, now I want to do is add parameter to Jenkins. Uh, Add parameter to Jenkins, wherein example I will enter the variable value, then only it will get changed in my repo and deploy. Yeah, you can use parameter in Jenkins. You have parameter support. You can just while running the builds and all, you can supply the parameter. You can run the builds. Yeah, that is one way to do it. Any idea how to do it for Bitbucket Stash? Um, if I like, let me know if I do you understand the question. You can just clarify it further. It's just about variable adding. You can add variables in say Jenkins. Okay, while running the build, you can supply the values, or you can use Bitbucket credentials. You can just go to Bitbucket settings, and there is environment variables you can inject. You can pass that one. You can fetch that one while running the builds in the say like this Jenkins, and you can reuse that one. That is another way. So just refine the question. I'm able to answer it further or more better way. What to do is add parameter to Jenkins. So simple. Since you are mentioning adding parameter to Jenkins, I will say multiple ways you can do it. You can add environment variables parameter for the particular project, or you can give like kind of name parameter in Jenkins. That is also possible. Multi-parameter. That is plugin is also available for multi-params. You can use that one as well. So yeah, multiple ways you can achieve this parameter adding part. Pretty easy, by the way. If you just a bit search and you can just experiment, you'll be able to get it done. Yeah. Feel free to add any questions. I think we have 6 minutes, right, Viraj? So like anyone can go ahead and ask any question they might have. I think we completed before time. Okay, looks. So yeah, 5 minutes left, guys. Any questions? I'll be happy to answer. I think people are more concerned. I mean, should be concerned about the CI/CD part because the project I have working on everywhere actually everyone deploying the cloud resources via the CI/CD. No one does manual. I mean, testing is okay, but real life no one does manually these days. All they're configuring in the cloud. In CI/CD could be Jenkins, could be Bitbucket pipelines, or could be just GitHub actions. There we configure all that. We don't do it manually these days for productions, by the way. Okay. Need a session on CI/CD. Yes, yes. I have multiple CI/CD on my channel. I'm kind of like last few years I was doing a lot of CI/CD. Now I'm these days teaching the basics. Like complete DevOps course I'm running on my YouTube channel, which these days again a lot of workload, so getting delayed a bit here and there. But yeah, some question about Docker. So Viswanath have some question on Docker. Yeah, feel free to ask any real-time example project of the companies using. Like many companies using it, we cannot exactly share the company secret of the company, which kind exact things they're doing, but many companies are doing it based on their requirements. We always want maybe some services or some some resources running in AWS, some services may be cheaper in Google. We do a lot of these things. Any some question about Docker? Yeah, if you anyone have any question about Docker, feel free to let us know. I secured first prize in okay. So Rahul say it's that Rahul saying I secured first prize in AWS reinvent quiz eras. When I can expect my what is that? Any reinvent thing happen? I don't know. I think the reinvent that thing, right?
Okay, so in last meetup that all the goodies were distributed. So I'm not sure
Oh,
whether you were part of it, but in last quiz, the first winner was Sagar Utekar.
oh,
So I think, yeah. So I'm not sure which quiz you are talking about, but if you're talking about some previous quiz, then as we requested that you can come to the next upcoming meetup. Over there also, we would be distributing it. So if you have missed it, if you have missed the last one, you can come to the next one.
yes,
We
yes. We are actually planning something, right, Dheeraj? Maybe not the time to announce. I mean, or not, but yeah, something very interesting coming. By the way, I'm coming to Pune anyway. We will have very interesting feed there.
yes.
Okay, it's Vishwanath saying I have technical issue after deploying Docker in Ubuntu 18. Container assets cannot be compressed. That's a weird issue, to be honest. Why you need to compress the container size? No, that could be specific to Docker version. You can just upgrade a Docker version, then it might fix. Enable the experimental feature Docker. That certain kind of feature as experimental in Docker is there for size comparison compression. You can use that one as well, but you don't have the requirement. I think usually for compressing the Docker image. Yeah, it again it's based on the error logs only. I can say much further, but as far as I remember, you can use a kind of experimental feature to solve this one, or just upgrade the version of that your Docker. That will also help it. I think yeah, we are all good. I think. Oh, how do you? I think for you there is a question, Rama's question. You must answer that, Dheeraj. This.
So Rama, to become a community builder, you have to actually have a good amount of contribution in terms of technical blogging, or in terms of YouTubing videos, or in terms of you sharing your knowledge with wider audience where you have conducted some workshops. So to become a community builder, there is no hard and fast rule. The only thing, the main gist of that specific program is they want people who have the passion to share knowledge to a wider audience uh, about what they know. And even though there are many resources that we have, for example, suppose if I speak on Terraform, right, that doesn't mean you cannot, because everyone has a different style of conveying it, writing a different blog, creating a different video. You have to see that what is going to bring value to the audience, and based on that you can start doing some content creation and share that specific content creation that you have done for the upcoming AWS community builder application. And I'm very sure that definitely they will consider that for your application.
Awesome. I think someone asked me how to become hero as well few days back. I say keep doing the great stuff that you are doing, maybe want to do. You will eventually become AWS hero. So yeah. That's like how we become AWS hero. I mean, how I became AWS hero, how you become AWS container, that community builder, and you also become. Oh, by the way, we are both actually Terraform ambassadors, right? Maybe we should add in the title as well, right? People will know, okay, we are the ambassador, both ambassador. So yeah, yeah, kind of pro in Terraform.
That's a good idea, Sandeep. I take that input. So I think I would
Yeah.
have to create an overlay based
Mm,
on the people that I'm inviting. So that overlay can showcase that, okay, these are the Terraform, sorry,
exactly.
not the Terraform, the HashiCorp ambassadors who are driving this event. So I can take that as
Exactly.
input.
Yeah,
Yeah,
that will be cool.
yeah.
Okay, it's Rahul. One question I think have. I have. Okay. Yeah. So can you hear me? Okay.
Yes,
So
Krishna
in a,
here.
yeah, yeah, is a PDR plan must be implemented like disaster recovery? How could you consider it from security point of view? I mean, DR plan should be from the day one. You have to plan it accordingly because anything can happen. Your region can go down. Your liabilities can easily go down these days, right? Anytime can happen. So you should have a disaster recovery plan. And how should have it? What is the time to recovery and what is the loss of the all the stuff you have to calculate. Then you have to find out the plan out the proper way to recover. Do you want to create a separate region or how what are the service can be restored quickly? What are the pain point services? You have to plan carefully execute. You can use chaos monkey kind of tool to actually create such situation, and how your solution can automatically recovering from that. You should do all the experiment that or the big companies does. Small companies, they don't have the resources to do that anyway. Yes. Okay, seems like you answer all the questions.
And people who are looking for in-depth knowledge, they can definitely visit Sandeep's YouTube channel. So Sandeep has a lot of crash courses in regards to that Jenkins CI/CD tools, and he also have a very good collaboration calls with different YouTubers who are actually making a
Yeah.
big difference in sharing their knowledge on YouTube.
Yeah, but we cannot share the name yet because that will be problem. Well, definitely when the things like we have a YouTuber here, like Dheeraj. Similarly, with Subham, we had one very. I Guru had a very interesting one. So yeah, we'll keep planning this kind of thing with other YouTubers as well.
Yes.
They have to approach anyway. I should be approaching them, but I have less time. This just, to be honest, so much work pressure. Dheeraj know how much work pressure I have. He calling and meeting going on. So yeah,
Okay.
this is the thing.
So I guess Sandeep, then it's time now. Thank
Yes.
you so much for joining this, not joining, inaugurating this specific series of a workshop where we would be talking less and we would be doing more, and which might help people to have practical hands-on about the concepts that are everyone use as a jargon, that it is multi-cloud deployment or different things,
Yeah,
how it
yeah,
is evolved.
exactly. I think there is any hardly any video on multi-cloud deployment in YouTube
Yeah.
probably. I think we are
Yes.
the first guys making it multi-cloud deployment.
Yes. Yes. Yeah. And I hope people who might have checked this. So, guys, even though if you're not able to do it, don't worry. So you will be having this recording, and apart from that, I would create a specific Git repo
Hmm.
in which whatever sessions we are doing as part of this specific series, that is workshop series, all the code is going to be relying on that specific Git repo. You can go ahead and you can use that. And if you have any questions in regards to that specific Git repo code, you can definitely reach out to me or Sandeep, and definitely we will try our level best to answer your queries. Okay,
Yep,
so
yep.
I guess then it's time to say goodbye. Thank you, Sandeep.
Oh yeah, but whoever watching, don't forget to subscribe Dheeraj channel. By the way, you guys are watching and forgetting why. Subscribe Dheeraj channel. So he making cool videos. He making cool series. By the way, should be doing that. Yep.
So thank you, Sandeep, for that. So see you guys. So for next week again, there would be exciting workshop, which you might have not heard of. I would be declaring it by Sunday or Monday, and again that is going to be a hands-on and real-time use case. The same way Sandeep has shown, it is again going to be in the same way. So I would give you just a hint that it would be on HashiCorp Vault, how you can use it in real-time scenario. So I would be sharing the details. So people who are interested, maybe this time you were not prepared for the series. Next time you can be prepared that what exactly the workshop goes with, and you can do it parallelly for the next time. So stay tuned. I will. I am going to share the announcement very soon with all of you. Thank you, Sandeep, for joining the series, and thank you all of you guys, and thank you all the viewers for joining. And it was a great collaboration with all of you, and fantastic questions. I really admire the questions that you're asking. It is to the point, and it is a very real and generic questions that comes when you are doing it. It is not like on the fly questions that ऐसा कर सकते हैं क्या? It's not like that. It's like if we are facing this problem. So thank you so much for the engagement, guys. So see you in the next weekend with some new workshop. Thank you and have a great weekend ahead. Thank you, Sandeep. Bye,
Thank you for
guys.
having me. Bye, everyone. Have a nice day. Happy holidays. Bye.